So in this last section, we're going to go through 3 examples where we basically are given a starting material, which will be benzene, and we're asked to make a specific product. So let's take a look. In the first example, we start with our benzene, and ultimately we want to make a benzene with a nitro group and a chloro group, like so. Now, this is not a mechanism. So we're not going to write the mechanism of each reaction, but we're going to look at how do we get from here to here. And this one, you can tell that it's going to be a multi-step synthesis because we're adding 2 different groups, right? You might have a single step if you're adding the same group twice. It might be possible. But in this case, we're adding a nitro group and we're adding a chloro group. So we have to think about, well, how do we add a chloro group and how do we add a nitro group? If you remember, we had a nitro group by adding nitric acid and sulfuric acid. We had a chloro group by adding chlorine and FeCl3. So that we know how to add both of these things. But the other thing we need to ask ourselves is, which order should we add these things in? And this is going to have to do with the activating and deactivating properties of the molecule. If you look here, these 2 are meta to each other, which means that we want to add the meta director first so that the second compound is added meta. Well, which one of these 2 is a meta director? I guess it could theoretically be both. In this case, we have a deactivating group that is a meta director because we have the positive on the nitrogen. In this case, we have a chlorine, which is a deactivating group, but it's also an ortho-para director. So in this case, we want to add the nitro group first. So we're going to add our HNO3 and our H2SO4, and what we'll end up with is a nitro benzene. We then want to add our Cl2 and our FeCl3 in the second reaction in order to make this product. So this is the overall reaction, and this is how we get there in steps. And I just write it this way so I don't have to write these twice, okay? But that's basically that. Let's look at another example. In this case, we're starting with benzene, and what we want to make is a benzene ring with a CH2 in the middle, and that's a 2, another benzene ring. So we've gone from 1 benzene ring to 2 benzene rings. I'd like to give you a second to, or suggest that you stop this video and you think about how to do this. If I was teaching this in a class, I wouldn't just tell you the answer, right? We would talk our way through it, and I would ask questions as we're going along. But this isn't interactive like a real class is. It's just a video. So basically, how are we going to go from here to here? Well, what was the difference is what I want to look at. I notice that I've added to this ring another ring and a CH2 group. So I'm thinking to myself, is there any way that I could add this directly? And the answer is no. There's no good way to add this directly. But how could I get here? Well, the first thing I could do is I could add a ring attached to a C double bond O bond Cl. This will give me the basic structure that I need. I will have 2 rings attached by a carbon in the middle. In order to make this happen, I need to use AlCl3. So when I do this, I have a ring bonded to a C double bond O, and this C double bond O comes with its own ring. So in this case, I've added a ring and a carbon group, which is exactly what I wanted to do. But there's a problem here. The problem here is that if I add this ring and this carbon group here, I don't have exactly what I want. So I need a way to reduce this bond from C double bond O to CH2. Well, it turns out that this bond is exactly one carbon away, or is the first carbon off of the ring and the first carbon off of this ring. Said another way, if there was just one ring, we'd call that a benzylic carbon. And to reduce that, we would add hydrogen and palladium, and we would get the molecule that we want. Now, I've given you a big hint that all of these reactions will be 2 steps. If I was going to give something like this on a test, I would also let you know the number of steps that would be required to do the reaction, which is a good hint. Let's put it that way. All right, let's look at one last example to complete this chapter and work on our putting it all together stuff. All right, in this case, we have benzene, and what we want to make is a benzene ring with a CHBr CH3. Okay, so we want to add a bromo alkane chain, if you will, to this. So we talked about how to add alkyl groups to benzene, but we never talked about how to add halo alkyl groups to benzene. And again, a hint is that this is 2 steps. You're not going to be able to do this in 1 step. So how do we add the alkyl group to benzene? What we can use is our Friedel-Crafts alkylation, AlCl3, and in this case, CH3, CH2, Cl. All right. When we do that, we end up with CH2, CH3 attached to our ring. How do we brominate our ring? Well, we're at the benzylic position, okay, 1 carbon away from the ring, or the first carbon off of the ring. So if we add NBS in the presence of PHCO2, benzoyl peroxide, we can now brominate at that position. So in each of these 3 cases, we did a 2-step process to get from benzene to what we were trying to make. So once you've learned the reactions, then it's about putting those reactions together to get from where you're starting from to where you're going. And here, we're eliminating a lot of the subtlety of the rearrangements and the multiple products and the stuff like that, but we still have to chain those reactions together to get from the starting material to the product.